I'll explain the core idea behind the RANSACRegressor. It's a clever algorithm designed to fit a model to your data, even if some of that data is messy, outliers. It's not trying to find the perfect fit to every single data point, because that's often unrealistic. RANSACRegressor works by repeatedly trying different things. Think of it like a detective investigating a crime scene. You don't have all the evidence at once. RANSAC takes random samples of your data and tries to build a model from those. It repeats this many times to get a model that best explains the majority of your data. Imagine you're drawing a line through a bunch of points on a scatter plot. Some points will fall almost directly on the line. These are the inliers. They fit the model very well. Other points will be far from the line. These are the outliers. They don't fit the model so well and RANSAC will generally ignore them. That statement is wrong. RANSAC is probabilistic. It doesn't try every single possible combination of points to guarantee that it finds the absolute biggest group of inliers. It's more about efficiency. This isn't correct either. The whole reason to use RANSAC is to deal with those pesky outliers that would mess up other model fitting methods. RANSAC aims to fit the inliers well, not necessarily every data point. That's the key. RANSAC focuses on getting the lowest total difference between the predicted values from its model and the actual values from the inliers. No way. That would take way too long, especially for large datasets. RANSAC uses random sampling, which is much faster. It makes a reasonable number of attempts to find a good model, then stops. This is the main question, which explores the internal workings of RANSACRegressor after successfully fitting a model to data with outliers. The algorithm has converged, meaning it has stopped because a satisfactory model has been found. This question asks whether you understand how the RANSAC, random sample consensus, algorithm works within the scikit-learn libraries RANSACRegressor . We'll look at 4 possible outcomes after the algorithm finishes. It's like a detective story, trying to find the best fitting line despite some noisy data points. I think this statement is wrong. RANSAC is a probabilistic algorithm. It doesn't guarantee finding the absolute largest group of points that fit the model well. It's more about finding a good enough solution within a reasonable number of attempts. Think of it like searching for the best fitting piece in a jigsaw puzzle. You might find a good fit, but not necessarily the absolute best fit without checking every single piece. I believe this statement is incorrect. RANSAC is designed to handle outliers, points that don't fit the pattern. A perfect fit to all points is unlikely, especially if we have outliers. The aim is to model the main trend, ignoring the exceptions. It's like drawing a line through scattered points. You might not hit every point, and that's fine. This is correct. RANSAC's main goal is to find a line that minimizes the error for the points that actually fit the trend, the inliers. The errors are the distances between the points and the line. Minimizing these errors for the good points is the key objective. That's the essence of RANSAC. This statement is false. RANSAC uses random sampling. It's not going to check every possible combination of data points. That would take way too long. It stops after a set number of iterations or when it finds a satisfactory solution. We wouldn't want to wait forever for a perfect fit, right? This refers to the overall process of RANSAC, where we iteratively fit a model to randomly selected subsets of the data, identify inliers and outliers and refine model until convergence is reached. In each iteration, RANSAC randomly selects a small subset of data points to fit a model. Once data points are sampled, a linear model is fit to those points. This linear model can be a simple line, plane or a hyperplane. This model can later be used to classify data points as inliers or outliers. After a defined number of iterations, or when a certain criterion is met, e.g., a sufficient number of inliers are found, the algorithm stops, and the best model found is returned. I randomly select a small subset of data points from the complete dataset. This is the core of RANSAC's randomness. We don't look at every possible combination. Think of it like picking a few lottery numbers. You're not checking every possible number combination. I use the inliers to re-estimate the model parameters, potentially finding a better fit. This is like refining a recipe once you find out what ingredients work best. I improve the model, making it a better representation of the data. I determine which data points closely fit the model I've just generated. These are our inliers. Data points that don't fit well are outliers. It's like separating good apples from bad ones in a basket. I check if I've reached a predefined number of iterations or if the model is good enough, based on a threshold, or a tolerance level for the error. Think of this as setting a limit on how many times you try a recipe before giving up. I decide whether I am satisfied with the current model. If I have met my iteration or quality criteria, I've converged. The process stops. If not, I go back to randomly sampling again. Yes, I've found a good enough model. I return this model. No, the model needs further improvement. I return to the random sampling step. The algorithm iteratively keeps trying to find a better fit until the condition is satisfied. This is the title of the problem. We are analyzing whether statements related to RANSACRegressor convergence are true or false. RANSAC, or Random Sample Consensus, is a robust algorithm for fitting models to data that contains outliers. It's a clever way to deal with noisy data. This is the core question that we'll be answering throughout this problem. We will determine which statements regarding the RANSAC algorithm's behavior upon successful convergence are true. I randomly select a small subset of data points from the entire dataset. This is the heart of RANSAC's efficiency. I avoid checking every possible combination. Think of it like picking a few lottery numbers instead of trying every possible combination. After fitting a model to a sample, I check how well it fits the rest of the data. I count the number of points that are close enough to the model, the inliers, and measure how far the inliers are from the model's predictions, the residual error. A lower residual error indicates a better fit. I use the randomly chosen points to fit a simple linear model. This could be something like finding the best straight line through the points. I repeat the process of random sampling, model fitting, and evaluation many times. Each iteration gives me a potential model. I'm looking for the model with the largest number of inliers and the smallest residual error. This iterative approach is what makes RANSAC robust to outliers. After many iterations, I select the model that has the largest set of inliers, minimizing the total error from that set. This model is my best estimate of the underlying relationship in the data, even with the presence of outliers. This is just a summary of the above steps. RANSAC, Random Sample Consensus, is an algorithm to estimate parameters of a mathematical model from a set of observed data that contains outliers. The algorithm is not deterministic. Instead, it has a stochastic nature, producing results that differ on each execution. I randomly select a small subset of data points from the dataset. This is a crucial step because RANSAC's power comes from its probabilistic nature. It doesn't exhaustively check every possible combination. After fitting a model to the sampled points, I identify the inliers, the data points that closely follow the model. The definition of closely depends on a predefined threshold. I repeat steps 1 to 4 multiple times. I keep track of the model with the most inliers. The algorithm stops when I reach a predetermined number of iterations or when the model's improvement plateaus. It's converged. I fit a simple linear model, or whatever model type you specified, to the randomly sampled data points. This is the model I will compare other data points to. Using only the points identified as inliers in the previous step, I refit the model. This step helps refine the model, as it's less affected by outliers. Yes, that's exactly right. RANSAC's main goal is to minimize the error only for the data points that fit the model well, the inliers, ignoring the outliers. Nope. That's computationally very expensive. RANSAC cleverly uses random sampling. It's faster and less prone to being trapped in local optima. No way. RANSAC is designed to handle outliers. A perfect fit to asterisk all points implies there are no outliers, which defeats the algorithm's purpose. Not necessarily. Because RANSAC uses randomness, it might not find the very best inlier set. It aims for a good enough set within a set number of iterations. I see this as a summary of how the RANSAC, Random Sample Consensus, algorithm works. It's an iterative process. First, I randomly select a small subset of my data points. Then, I fit a model, like a line, to that subset. Next, I identify which of my data points are close enough to my model. These are the inliers. I then refit the model using only the inliers. I repeat these steps until my algorithm converges, meaning it stops improving, usually because it's reached a set number of iterations or some other convergence criteria. This is the first step of RANSAC. I randomly choose a small number of data points from my entire dataset. This helps make my algorithm efficient, especially with large datasets. After randomly selecting my data points, I fit a model to these points. For example, if my model is a line, I find the line that best fits this random subset. I identify the data points that are close enough to my model. These are the inliers. Points that are far away are outliers. How close is close enough depends on my tolerance or threshold setting. I now have a set of inliers. I refit my model, like my line, using only these inliers. This gives a better, more accurate model. I repeat steps 1 through 4 many times, hoping to find a model that's very close to most of my inliers. I stop when my model improves only a small amount or I've reached a predefined number of iterations. I need a way to stop my RANSAC algorithm, so I set some rules. I either put a cap on the number of iterations or set some condition for my model's improvement. For example, if the number of inliers doesn't increase significantly in successive iterations, or the difference in fit quality is negligible, I conclude the algorithm has converged. Pretty clever, huh? This question is testing my knowledge about the results of a successful RANSACRegressor. I have to determine which statements accurately describe the algorithm's state after successfully converging. This statement is false. RANSAC doesn't guarantee that I find the absolute largest set of inliers. It's a probabilistic method, so I might find a good inlier set, but not necessarily the very best one. This statement is false. RANSAC is designed to handle outliers. I'm aiming for a good fit to the inliers only, not a perfect fit to every single data point. Outliers are excluded from model fitting. This statement is true. The core idea of RANSAC is to minimize the error of the model on the data points that fit, the inliers. This statement is false. RANSAC uses random sampling, not an exhaustive search. If I checked every possible combination, it would take a ridiculously long time for even moderately sized datasets. This is the title of the quiz question. I'm asking whether a RANSACregressor, a type of regression algorithm that uses the RANSAC method, successfully converged, meaning it found a satisfactory solution. Here's the core problem. We're using the RANSACregressor in Sklearn, a popular Python library for machine learning. It's a tool that fits a linear model to data, even if that data contains outliers, data points that don't fit the pattern. The algorithm converged, successfully found a solution, after running through several iterations. The question asks which statements about how it works are true. This statement says the RANSACregressor focused on minimizing the difference between the model's predictions and the actual values for the inliers, the good data points that fit the model well, not including the outliers. That's exactly what RANSAC aims to do. This statement is wrong because RANSAC doesn't check every single combination of data points. That would take forever for large datasets. Instead, it randomly samples some points, fits a model, and repeats. This is false. RANSAC doesn't guarantee finding the absolute biggest set of inliers. It's a probabilistic algorithm that aims to find a good enough set within a reasonable number of iterations. This is also wrong. RANSAC is specifically designed to handle outliers. It doesn't try to fit every single point perfectly, because some are outliers that should be ignored. The goal is a good fit for the inliers only. This is a section header summarizing the overall process. This step describes RANSAC's first action, randomly selecting a subset of the data points. After randomly selecting points, RANSAC fits a model, in this case, a linear model, to those selected points. Then RANSAC calculates how well the model fits the entire dataset by computing the difference between the model's predictions and the actual values, the residual error. Smaller errors mean a better fit. RANSAC repeats steps 9 to 11 multiple times. It stops when it's satisfied that it found a good enough model, or it reaches a preset number of iterations.